We are welcome to Science Planet, and today we are analyzing a Waec 2025 quantitative analysis of sodium bicarbonate and HCl. Okay, so this is a predicted question, and here we have A is a solution containing 1.83 gram HCl per 500 cm cube of solution. B is a solution of impure NAHCO3 containing 9.60 gram per dm cube. A. Put A into the burette and titrate it against 20 cm cube or 25 cm cube portion of B using methyl range as indicator. Tabulate your readings and calculate the average volume of acid used. B. From your results and information provided above, determine the 1. Concentration of A in mole per dm cube. 2. Concentration of B in mole per dm cubes. 3. Percentage purity of NaHCO3. 4. Volume of CO2 liberated at 53 degrees Celsius. 5. Amount of Na ion present. 6. Amount of hydrogen ion present. So here we are done with our titration, and we have our average volume to be 25 cm cube. If you look at the table, you can see we summed up our first titer, second titer, and third titer, and we got our average volume to be 25 cm cube. So here in calculating the concentration of A in mole per dm cube, first of all we have to have our mass of HCl in 1 dm cube. Remember, our A is our acid HCl. So in calculating that, we have 1.83, which is our gram, times 1000 over 500. Remember, converting cm cube to dm cube, you have to divide by 1000. So that's why you have 1000 there. So when you are done with your calculation, you should be having 3.66 gram dm cube. So our gram per dm cube, you have to convert it to mole per dm cube, and in converting to mole per dm cube, you have to divide with the molar mass, and dividing with the molar mass is the molar mass of HCl. So you now have to calculate the molar mass of HCl. So adding them up, the molar mass of HCl is 36.5 gram per mole. So generally we have to divide the 3.66 with the 36.5 to get our 0.10 mole per dm cube. So this is the concentration of A. Looking at question number 2, concentration of B in mole per dm cube. Okay, so we look at the equation between the sodium bicarbonate and HCl. So to give us sodium chloride plus water plus carbon dioxide. Okay, and the moles between our acid and base is 1:1. Okay, so you use this formula CAVA, TAVA equals to Na over CBVB equals to NB. Okay, although in this place I didn't use the Na and NB because it's the two of them are in ratio 1:1, so it's negligible because one wouldn't make a difference. So that's why you didn't see the Na and NB. Okay, so but you can still use it, Na, NB. The mole ratio are 1:1. So we have our parameters here. We have our Ca to be 0.10. Our volume of acid, remember, is 23, and our Cb is what you are looking for. So Vb is volume of pipette, the pipettes we use. So we asked to use either 20 or 25, so I use 25 here. So when you are done with your calculation, you should be having 0.10 mole per dm cube for your B. So in calculating the percentage purity of sodium bicarbonate, remember the formula is mass of pure sodium bicarbonate over mass of impure sodium bicarbonate times 100 over 1. So here they have given the concentration of impure sodium hydroxide as 9.60 gram. So what we need to do is to calculate the relative molecular, the molar mass of sodium hydrogen triazoxide carbonate, that's sodium bicarbonate, calculating it to give us 84 gram per mole. So what you need to do again is to get the mass of the pure NAHCO3. So in order to get the mass, remember the mole of the NaHCO3 is 0.10 mole per dm cube. So multiply it with the relative molecular mass. Okay, this formula comes from the mass equation of stoichiometry. So multiply it with the relative molecular mass, so you'll be having 8.4. so you put your parameters, so your mass of pure will be 8.4 gram per dm cube, while your mass of impure will be the 9.60. so multiply it by 100, and when you do your calculation, you'll be getting nothing but 87.5%.